Good morning everyone. So in today video lecture we will discuss another type of carbohydrate, that is oligosaccharide. So in last class we discussed about monosaccharide. So here what is oligosaccharide? So here oligosaccharide, which is mainly comprises of two or more than two monosaccharide units to form oligosaccharide. In oligosaccharide we have different types based on the number of monosaccharide units. For example, here if two monosaccharide units together form disaccharide. So in disaccharide, there are two monosaccharide units together form disaccharide. So here we have two examples for disaccharide units. We will discuss in depth of disaccharide units like sucrose, and we have lactose, and also we have maltose, and also we have trehalose. So all these are the disaccharides carbohydrates. Now coming to second one, if there is a three monosaccharide units together form tri. So in trisaccharide, there are three monosaccharide units together form. So best example here, raffinose. We will discuss about raffinose, how this raffinose will get formed. Now coming to if there are three monosaccharides units, if there are three, here I am writing, if there are three monosaccharide units together there are four monosaccharide units together form tetrasaccharide. So here best example for tetrasaccharide is stachyose. Now coming to last one, so here the fourth one, in which there are five monosaccharide units together form penta. So likewise we have different types of oligosaccharide. So here best example for pentasaccharide, that is verbascose. So likewise we have different types of oligosaccharide. So we will discuss in detail about disaccharides, in which we will discuss sucrose, lactose, maltose and trehalose. So before we discuss this oligosaccharide, let's know about two important terms. Here we need to know two important terms. So like they are, in which we have seen we have two types of sugars based on their donating electrons. So here I am writing, we have two types of sugars. Just wait. Yeah, two types of sugar we have, like reducing sugar and non-sugar. So what exactly reducing sugar we will discuss here. So here reducing sugar means here the sugar which have free aldehyde group or keto group. Free aldehyde or ketone group is available. The sugar which has free aldehyde or ketone group, and so they can easily donate electron to the other molecule. Such type of sugar is called reducing sugar. So here best example for reducing sugar, like all monosaccharides. So what we discussed in last class, all comes under reducing sugar, and also very important in disaccharide sugar. So remember in disaccharide, not all disaccharide, only two disaccharide only they comes under reducing sugar, like lactose and maltose. So this in disaccharide, lactose and maltose are reducing sugar, and all monosaccharides are reducing sugar. So in which there is a free availability of aldehyde group or ketone group. So easily we can donate the electron to the other molecule. So this type of sugar is called reducing sugar. Now coming to here, non-reducing sugar, we will discuss here. Non-reducing sugar, here I am writing. So it's quite opposite. Here no availability of in non-reducing sugar, no availability of free aldehyde group or ketone group. Hence, they do not donate electron to the other molecules. If any carbohydrate which do not donate to any electron to the any other molecule, such type of sugar is called non-reducing sugar. So here best example for non-reducing sugar, very important, all polysaccharide. We will discuss in next video about polysaccharide. So all polysaccharide comes under non-reducing sugar. And also here we have disaccharide. In disaccharide there are only two sugar only comes under this non-reducing. Those are sucrose and trehalose. So this sucrose and trehalose are disaccharide, but it is non-reducing sugars. So like that we have two types of sugar based on their availability of free carbohydrate groups or ketone groups. Okay. Right. Next we will discuss in detail about disaccharides. So in disaccharide there are two monosaccharide units. So here first two disaccharide we will discuss. So that is sucrose. Here sucrose. Common name for sucrose is cane sugar or table sugar. So here the sucrose, which is formed by two monosaccharide units. Those are glucose and fructose. So this glucose and fructose both are monosaccharides and together form sucrose. So remember here how they are formed means like this. So in the glucose structure will be like this. Here I am. Yes. So this is the glucose structure. It has glucose has pyranose ring form, pyranose ring structure, glucose. So it is a alpha D glucose. And here fructose has pyranose ring structures. Pyranose ring structure means like this. So here we have carbon number. Where is carbon? Here we have carbon like this. So in between these two together form sucrose. How means in between here we have various bonds. So here generally this will form between, and it is alpha D for glucose, and here there is a bond which is formed, that is alpha 1 comma 2 glycosidic bond. So means here this is the structure of what? Pyranose ring structure of pyranose ring like structure of fructose. So in which here in glucose here first carbon, second, third, fourth, 5 and 6 carbon. Here see here, and here second carbon. Means here 1, here 2, second carbon, third, 4, 5, 6. Okay. So see in between first and second here. In between here first and second only the bond will form. Means here we have H, here opposite we have O and H, second carbon. So how the bond will form means like this. From the bond is here glycosidic bond between two monosaccharide units will form by removing oxygen, sorry water, by hydrolysis like this. So and here H. Okay. So by removing H2O, here H2O bond will be removed, and then there is a bond which is formed. That bond is called alpha 1 comma 2 beta glycosidic bond. So due to 1 comma 2 glycosidic bond which is bond formed between glucose and fructose. So hence they form the structure of sucrose. Like that they will form. And remember, so after form this bond, glycosidic bond, O glycosidic bond will form. And then here, so once the sucrose which undergoes hydrolysis by enzyme, so here it undergoes hydrolysis enzyme. Here hydrolysis of sucrose enzyme is invertase is an enzyme which hydrolyzes this sucrose, so also known as sucrase enzyme. So just now we discussed sucrose is a non-reducing sugar. It is a non-reducing sugar. Why? Because in which no free aldehyde group and ketone groups are available. In which, so here no free aldehyde or ketone group is available. Okay. So here important note here, you want to know that, so before hydrolysis the sucrose shows, here I am writing two important note. Before hydrolysis this sucrose shows dextro-rotatory rotation. Dextro-rotatory means plus, optical rotation. So it has plus symbol. And after the hydrolysis of sucrose, it shows levo-rotatory optical rotation. So there is a major differences before hydrolysis and after hydrolysis of sucrose. So this is all about the sucrose. Okay. So next disaccharide, that is lactose. So common name for lactose is milk sugar, and this milk sugar which is formed by 2D glucose and beta D important. So this lactose which is formed between two monosaccharide, one is glucose, second one is galactose. So by a bond here alpha 1 comma 4 glycosidic bond, how it is formed we will discuss. So here let's we discuss the bond which is how the bond which is formed, sorry, yeah, how this bond will form we will discuss here. Both are having pyranose ring form like glucose and galactose like this. Here we have, it is a glucose structure. So here this side we will do. So this is a galactose structure, galactose. So in galactose fourth carbon here 1 2 3, here 1, this 2, here 3, here 4, 5, 6, here 1 2 3 4 5 6, sixth carbon. So here in which the bond which is formed between 1 comma 4 glycosidic bond. So means in glucose here we have, you know that here also at fourth carbon we also have. So like that we have the structure in glucose, galactose and glucose. So here in between, so there is a formation of here, sorry, in which H and so remove water, and there is a form between alpha 1 comma 4 glycosidic bond between this glucose and galactose by removing water. Okay. So like that lactose will be formed. So if you want to hydrolyze this lactose, then we need one enzyme. So hydrolysis of lactose, we need one enzyme. That enzyme is called lactase enzyme. So lactase enzyme is essential for hydrolysis of this lactose. Okay, now next, third disaccharide, that is maltose. So here maltose common name malt sugar. So this malt sugar which is formed by alpha D glucose and alpha D glucose. So here both monosaccharides are glucose only. So two monosaccharide, same monosaccharide together form malt sugar. For example, if we have the glucose formula C6, here C6, here one more glucose C6. So when they are fused together, means they are formed together by glycosidic bond, and they lose one water molecule. So finally we have one formula for maltose. So that is C and O11. So this is the whole formula of maltose. Why? Because in which here, by here we have carbon number 12. Okay, as it is here H12 24, but they lose in the form of one water molecule. Hence the carbon number is only here, hydrogen is 22, oxygen is 11. Okay, so this is the formula of maltose. So how the bond will form, we will discuss. So both we need to draw same glucose structure like this. Here also this side, and here we need what, both are must be glucose structure here like this. Why? Because this maltose which is formed from the glucose molecule only, both glucose monosaccharide only. See example here. So here carbon number 1 2 3 4 5 and 6, here 5 and 6, 1 2 3 4 5 and 6, like that we have 6 number carbons. They are pentose sugar, no, sorry, hexose sugar. And here, so this bond which is formed between alpha, here 1, here we have, here also we have, okay. So here the bond will form like this, H from here, so remove in the form of water molecule, and there is a bond will be formed like this in between this. So this bond is called alpha 1 comma 4 glycosidic bond. So this alpha 1 comma 4 glycosidic bond formed between glucose molecule, two glucose molecule, by removing water molecule. So then it form maltose. And to hydrolysis of this maltose we required, so hydrolysis of this maltose we required an enzyme called maltase enzyme. Maltase enzyme we require. So once if this undergoes hydrolysis, means they again form into two molecule of monosaccharides. Two molecule of monosaccharide units, means they will get separate. So in hydrolysis, generally in hydrolysis what happen? There is the addition of water again. So if breakdown of this water molecule, and what are the water molecule which is removed during formation of glycosidic bond, and once it undergoes hydrolysis, then with the help of water molecule only, there is a form of, and means it to separate two monosaccharide units like glucose. So two glucose molecule will be again formed by hydrolysis of maltase enzymes after break of this maltose sugar. Okay, so like that. And coming to last and one more very important disaccharide sugar, that is trilose sugar. So here the common name for trilose sugar is the insect sugar, which is generally seen in insect blood. And insect blood, in insect blood the common sugar is trilose sugar, remember. And this sugar is formed by alpha glucose and also alpha glucose. Same here also, two monosaccharide units are glucose only. Here in maltose also two monosaccharide units are glucose, but we have the major differences in between glucose and glucose. The bond will form between 1 comma 4 glycosidic bond, but here the bond will form on this trilose sugar which is formed by alpha 1 comma 1 glycosidic bond only. Here 1 comma 4 glycosidic bond, but here 1 comma 1 glycosidic bond. How means, for example, here if you see the both glucose structure like this, here also we need to draw one more glucose structure like this. Sorry, yes, like this. Okay, so here, so 1 2 3 4 5, and which is a one alpha glucose, this one also alpha glucose. So here between 1 and 1 here, so we have now, yes. So here by removing water molecule, there is a bond which is formed between 1 and 1 glucose. So alpha 1 comma 1 glycosidic bond will be formed between 2 alpha glucose. So that type of sugar is called trilose. But in trilose and maltose, the major differences here, alpha 1 comma 4 glycosidic bond, but here alpha 1 comma 1 glycosidic bond. So that is the major differences in bond formation. Okay, right. So this is all about the important disaccharides we discuss. So next, trisaccharides. So here trisaccharides are formed by 3 monosaccharide units. So best example here, raffinose sugar. So this raffinose sugar which is formed by 3 monosaccharides. So what are these 3 monosaccharides here? They are very important, which is formed by this raffinose or trisaccharide, which is formed by glucose and fructose, and very important. So here glucose, fructose, galactose. These three are monosaccharide. So these 3 monosaccharides together form raffinose type of trisaccharides. Best example. Okay, but here only one molecule of galactose only involved, but glucose and fructose are common. Okay, and also we can write this raffinose which is formed by glucose and fructose together form what? Sucrose. Just now we discussed in disaccharides. So also we can write it is formed by sucrose plus galactose, or also galactose. We can write like this only. So in how many galactose molecule here? Only one galactose. So raffinose is a type of trisaccharide in this raffinose which formed by glucose, fructose, galactose, or also we can write which is formed by sucrose or galactose. Why sucrose here? Why? Because glucose, fructose together form sucrose now. So sucrose plus galactose is equal to one sugar, that is trisaccharide sugar. Here best example for trisaccharide sugar is raffinose, remember. So likewise we have one more type of oligosaccharide, that is tetrasaccharide. So in tetrasaccharide how many monosaccharide units? 4 monosaccharide units are, sorry, here monosaccharide units are involved. So best example for tetrasaccharide monosaccharide unit is stachyose. Very important. Stachyose is a tetrasaccharide oligosaccharide. Okay. So this stachyose which is formed by here, same glucose and fructose. But here very important, there are two galactose molecule, two galactose monosaccharide. In trisaccharide, in raffinose, only one galactose, but here two galactose are involved. So hence glucose, fructose, and two, but here two galactose, means there are 4 monosaccharide units together form tetrasaccharide, that is stachyose. Or also we can write like this. So glucose and fructose together form what? Sucrose. Or here to galactose. Also we can write like this. Okay, remember. So one molecule of sucrose, here one molecule of sucrose, two molecule of galactose is nothing but tetrasaccharide. Example is stachyose. And one molecule of sucrose, one molecule of galactose together form trisaccharide, that is raffinose, like that. Okay, right. One more and the last, that is pentasaccharide. Penta. So here pentasaccharide, penta means 5 monosaccharide units together form this pentasaccharide. Best example for pentasaccharide is verbascose, OSC, verbascose. So this verbascose which is formed by 5 monosaccharide now. So what are they? Here I am writing those 5 monosaccharides are here. Just wait. Yeah. So here 5 monosaccharides are here, in which here I am writing glucose and galactose. Sorry, glucose and first fructose. But here very important, 3 galactose molecule. 3 galactose. So also we can write like this. So glucose and fructose together form sucrose. So how many sucrose molecule? One sucrose molecule plus 3 galactose molecule. One molecule of sucrose, 3 molecule of galactose. So like 5 monosaccharide units together form pentasaccharides, that is verbascose. Okay, so like that we have different types of oligo. So by this we will complete oligosaccharide type of carbohydrate. So in coming video we will discuss polysaccharides. So thank you, have a nice day.